This is lesson 6.4. We are doing exponential functions. Okay, so it says an exponential function is a non-linear function. So before we've only dealt with linear, which means a straight line. Non-linear means we're going to look at stuff that is not a straight line. So it says of the form y equals ab to the x power. So I would write that down. That's like our y equals mx plus b for linear ones. Y equals ab to the x power. And it says where a cannot be 0, okay, so it could be anything else. B cannot be 1, and it has to be greater than 0, which means instead of saying greater than 1, it could be like 0.5. It can be between 0 and 1, but it cannot be 1, and it's anything above that. Okay, so it says as the independent variable x changes, the dependent variable is multiplied by a constant factor, which means consecutive y values form a constant ratio. Okay, that maybe sounds like a bunch of mumbo jumbo, but we'll dive into an example and hopefully it'll make sense. So they start us off pretty easy. It says, does each table represent linear or exponential functions? So on A, we just look at the pattern that's happening. Okay, so from 0 to 1, it goes up 1, 1 to 2, up 1, 2 to 3, up 1. Okay, then on bottom, from 2 to 4, you know you could either add 2 or multiply by 2. So you check on both to see. From 4 to 6, okay, we're adding 2 each time. Since we are adding on both of them, adding or subtracting, as x increases by 1, y just increases by 2. That has a steady rate of change or a constant or a slope of 1 over 2. Or technically it'd be y over x, so 2 over 1. So that is linear. That would make a straight line if we were to graph it. Okay, so then if we look at B, we have 0 to 1, which is plus 1, 1 to 2, plus 1, 2 to 3, plus 1. So still plus 1 on top, but then on bottom, from 4 to 8, we can either add 4 or multiply by 2. So then we check. If I add 4 to 8, that's not 16. So we are multiplying by 2 each time. 16 times 2 is 32. So since we were increasing by 1 on top, but then we were multiplying by 2 on bottom, that means it's exponential. That's not a straight line if you were to graph it. It curves. And they say, okay, so what they mean by it forming a ratio, if we check 8 over 4, 8 divided by 4 is 2. 16 divided by 8 is 2. 32 divided by 16 is 2. We're getting a constant ratio of 2, what we're multiplying by. Okay, so we're going to go ahead and look at something else. Now we're going to look at evaluating an exponential function. Remember, they're in the form y equals ab to the x power. So this first one, A, says y equals negative 2 times 5 to the x power when x equals 3. So this semicolon, remember, separates the problem. This is the problem, and we're going to solve it for when x is 3. So the first thing you do is rewrite it. We have negative 2 times 5 to the third power. Using our PEMDAS, or order of operations, we have to do this exponent before we can multiply. So that only goes to the 5 because the rest of it is not in parentheses. So 5 to the third power, meaning 5 times 5 times 5, is 125. Then we multiply by negative 2 to get negative 250. Okay, example B, y equals 3 times 0.5 to the x power when x equals negative 2. First thing we do is rewrite it. Now, on their steps, it looks super confusing on how they went from here to here. So what they did, 0.5 to the negative 2, we know, so that means 3 times, we have to do 1 over 0.5 to the second power. Okay, but 0.5 is really 1/2. So we have 1 over 2, which in itself flips to 2 over 1, but it's still raised to the second power. So 2 to the second power is 4. So then it becomes 3 times 4, which is 12. Even if you plug this in your calculator, it will show you 4. Okay, actually, I guess I better erase. I need some elevator music while I erase. Okay, so you're going to try, let's just do numbers 1 and 3. I'll give you one of each of those. Try number 1, try number 3, pause it, try those, and then I'll go over it with you. Okay, on number 1, we're determining if it is linear or exponential. So if we look on top, each time it is adding 1. And on bottom, to get from 8 to 4, it could either be to minus 4 or divide by 2, so then you have to continue. Minus 4 does not work there, so it is being divided by 2. Since it's being divided or multiplied, we know that that is exponential. Okay, on the other one, we are just evaluating. Y equals 2 times 9 to the x power for when x is negative 2, 0, and 1/2. So the first one is negative 2. We know when something's to a negative exponent, 1 over that number. So I have 2 times 1 over 9 squared. Really 1 squared too, but 1 squared is just 1. 9 squared, 9 times 9 is 81. So then we have 2 times 1 over 81. And I believe that comes out to half of 80 is 40.5. Forgot to grab a calculator. Okay. So it's going to come out to a fraction or a decimal. Because 2 over 1, they cross cancel. To where you're doing 81 divided by 2. 80 divided by 2 is 40, so 0.5. It just doesn't look right. If you get something different, that's okay. All right, then on y equals 2 times 9 to the 0 power. 9 to the 0 power is 1. 2 times 1 is 2. That one was easy. And then last one, 2 times 9 to the 1/2 power. If you remember, that means the square root of 9. Square root of 9 is 3. 2 times 3 is 6. Okay, so now it's going to start to get a little tricky. We're going to look at graphing exponential functions. So we are still using the formula y equals ab to the x power. Okay, so it tells us that's a vertical stretch, not Shrek, or shrink by a factor of a, of the graph of the parent function. So that sounds super confusing. Just know our parent function is going to be whatever the y equals b to the x is. The a tells you what's happening to the graph. Like if we go back and we had, okay, so this graph stretched by 2 because there was a 2 being multiplied, or this graph reflected because there was a negative. That's the kind of stuff we're going to look at. A tells us what's happening. Okay, so the y-intercept of your graph will also always be the A. So that's kind of helpful because that tells us where it crosses the y-axis at your A. So these look super confusing. But whenever y equals ab to the x, when b is greater than 1, you will have, I guess, going up or down to the right, because your b, is greater than 1, and if a is negative, it's going down. Then when b is between 0 and 1, meaning it's like a fraction or a decimal, it goes up to the left or down to the left, depending on if a is positive or if a is negative. If that made no sense, that's okay. Let's look at an actual example. All right, so we're first going to look at graphing it when b is greater than 1. So it says graph f of x equals 4 times 2 to the x power. Compare the graph to the parent function. Describe the domain and range of f. So one thing that they don't do that I feel would be helpful is go ahead and make a table for your parent function and fill both tables in at the same time. What I mean by that, go ahead and make another table with -2, -1, 0, 1, and 2. And you'll hear me say this repeatedly, I'm not super worried about the parent function. I'm mainly worried about the f of x. So again, we talked about a is what's happening to your graph. So the parent function of this, they always say g of x for the parent function on these, would just be 2 to the x. Okay, so as we fill in our parent function table, we'll be able to fill them both in at the same time. You'll see what I mean. So first thing we have is when x is -2. So if I plug in 2 to the -2, I know to make that positive, I have to do 1 over 2 squared. 1 over 2 squared is 1 over 4. So my parent function here would be 1 over 4. Well, to get the new one, we do 2 to the x, which I just did, which is 1 over 4. Now times 4. 4 times 1 over 4, the 4's cancel, and it's just 1. Okay, so then let's fill in for negative 1. 2 to the negative 1 would become 1 over 2. Then for f of x, you just now take and multiply that by 4. 1/2 times 4 is 2. Okay, then 0. 2 to the 0 is just 1. 1 times 4 is 4. So then 2 to the 1, that's just a 2. Then I have times 4, which is 8. So the only difference, you have to basically find your parent function first, then multiply it by whatever's out here. So 2 to the second power, we know it's 2 times 2, which is 4. Then we have times 4, which is 16. So then we can graph those. If we graph these points, that's our parent function. Again, see, they don't even show the points, not super worried about it. Your new one, so we have the point negative 2, 1, negative 1, 2, 0, 4. Again, that's where the y-intercept should be because that's what A is. 1, 8, and 2, 16. So then if you notice when we draw our line, it starts shooting up rapidly. That's what exponential means. It grows increasingly fast. Okay, so last thing we have to do, we can talk about it. I don't care about you writing this down. It's more of just a verbal thing. It had a vertical stretch by 4, a factor of 4. That was the only thing that happened. Domain and range, we do have to do that. The domain is your x values, and you're only looking at the f of x one. So if you notice on the negative way of the x-axis, it just continues. And the positive way, we don't know where that stops. We just know it continues. It can continue that way eventually. So your domain is all real numbers. The range, which is looking at your y-axis, if you notice, it continues up forever, but it comes down here. It never goes below that. So that would be y is greater than 0. There's your domain and range. Okay, I know that's a lot. So now we're going to look at another problem just like that, but this one is when b is going to be between 0 and 1. So we're going to get a nice fraction. Yay! I know you're so excited. Okay, so I know these are not easy, so it's okay if you feel confused. They're a bit confusing. We have same thing, but now a fraction. So we have f of x equals negative 1 over 2 to the x power. So my parent function on this one is super close to it. The only thing that's different is there is a negative. So the parent function is 1 over 2 to the x. So being that all that's happening is a negative is being multiplied, that means it's going to be a reflection across the x-axis. So for my parent function, if I plug in negative 2 for x, 1 over 2 to the negative 2, it would flip. And you have them both squared. 2 squared is 4, 1 squared is 1, so 4 over 1 is 4. Then you have times a negative, so negative 4. Okay, that's how they're getting these numbers. They're just plugging them in for x. So 1 over 2 to the negative 1, it would just flip to 2 over 1, which is 2, times a negative is negative 2. 1 over 2 to the 0 is just 1, times a negative is negative 1. 1 over 2 to the 1 is just 1/2, times a negative is negative 1/2. And then 1 over 2 to the second power, 1 squared is 1, 2 squared is 4, so 1 over 4 times a negative. Okay, so I'm just going to look at graphing the f of x, not worried about the parent function, since the parent function is just a reflection. Okay, so we have negative 2, negative 4, negative 1, negative 2, 0, negative 1, 1, negative 1/2, 2, negative 1/4. So if you notice, when we draw our line through that, it's curved, it's going down over here, and then it's getting super, super close to 0, but it never crosses it. So to state our domain and range, looking at domain, that's your x. It continues that way and that way. So domain, as it will be most of the time on these, is all real numbers. Range, your y. It's going down forever and it never crosses 0, so y is less than 0. All right, so I know these take a while, so I just want you to do your best, but I'm going to have you try 5 and 6. We'll do one where b is greater than 0 and one where it is between 0 and 1. So pause the video, try those, and then I will go over it with you. Okay, on 5 and 6, we are graphing the function and the parent function, comparing it, then stating the domain and range. Okay, so looking at this, the parent function would be 4 to the x power. Okay, I guess I'll do a separate table for that. Which we can go ahead and compare it looking at that. It's being multiplied, so that would be a vertical stretch of factor of 2 and a negative outside, which means it is a reflection across the x-axis. So it had two things happening to it. Okay, so let's plug these in. 4 to the negative 2 power, whoopsie. Okay, 4 to the negative 2 power means 1 over 4 to the second power. 4 to the second power is 16, so 1 over 16. So then for this one, I'm kind of combining them at the same time. So I should have grabbed a calculator. 1 over 16 times negative 2, that just comes out to negative 1 over 8. Okay, let's see then 4 to the negative 1 power. That would just be 1 over 4. And then 1 over 4 times negative 2 is negative 1 over 2. Then 4 to the 0 power is just 1. 1 times negative 2 is negative 2. 4 to the first power is just 4. And 4 times negative 2 is negative 8. And then 4 to the second power is 16 times negative 2, negative 32. Okay, so now we can graph. I think I have enough room. So 1, 2, 3, 1, 2, 3, 1, 2, 3. So I might have to count. It goes up to 32. It goes up pretty big. So I might have to count. That would still be 17 lines. I may count by 4s. 2, 4, 6, 8, 10, 12, 14, 16, 18. 4, 8. Okay. So negative 2, negative 1 over 8. That's like really, really close to 0. So that's below the line. Negative 1, negative 1/2. Oh, it's going, dadgummit. Sorry, y'all, I just realized I drew that line because it's a reflection. The parent function, if you know, is positive. So the parent function is going to look like this. But the one we're doing is going to be the opposite because it's a reflection across the x-axis. I wasn't thinking. I should have done the line more like this. Okay, so we have negative 2, negative 1 over 8, close to 0, negative 1, negative 1/2, 0, negative 2, 1, negative 8. And I'm just going to stop there because 2, negative 32, it's way on down. Our line is doing this. Okay, so then the parent function, if you graph it, I'm not so worried about graphing the parent function. It would be this way. Okay, so we have our domain, which is your x values. It continues that way and this way, so it's all real numbers. The range, if you notice, never gets to that, so y is less than 0 because it is below it. Okay, on example 6, the parent function of that would be 1 over 4 to the x. So it looks like it's just multiplied by 2, so that would be a vertical stretch by a factor of 2. Okay, so I have 1 over 4 to the negative second power, which means we're going to flip that to the second power, which really it goes to both of them, but 1 times itself is just 1, so 4 squared is 16. Then I have times 2, so now I have 1 over 4 to the negative 1 power, which just flips it to 4 over 1, which is 4, times 2 is 8. Then 1 over 4 to the 0 is just 1/4. 1/4 times 2 is 1/2. Then 1 over 4 to the 1 is just 1 over 4. Oh, good grief, I realized I did that wrong. I hope y'all caught that by this point. 1 over 4 to the 0 is just 1. 1 times 2 is 2, because this one is 1 over 4 times 2 is 1/2. And then the last one, 1 over 4 to the second. 1 squared is 1, 4 squared is 16, so 1 over 16 times 2 is 1 over 8. Okay, so now we have all positives since there was no reflection. I may count by, it goes all the way up to 32. I guess I'm going to have to count by 4s. 4, 8, 12, 16, 20, 24, 28. 32. Okay, so we have, I'm going to graph, I guess I better graph the parent function on this one. I'll graph it in blue, just so we can see it. Again, I'm not so worried about the parent function. So I have negative 2, 16, 4, 8, 16, negative 1, 4, 0, 1, 1, 1/4, 2, 1/16. There's our parent function. So then our new function, have negative 2 at 32, negative 1, 8, 0, 2. Good Lord. 0, 2. 1, 1/2. 2, 1 over 8. So there's our new one. Okay, so our domain, again, looking at the x-axis, is all real numbers, and our range, or your y, is greater than 0. Okay, on this one, now it says graphing when we have y equals ab to the x minus h plus k. So what we will do, let me get a pen, is initially just graph this. Okay, so then the minus h, or plus h, whatever that is going to tell you how to go horizontally, horizontal units. And the k, being added or subtracted out here by itself, is a vertical translation, which means up or down based on whether it's positive or negative. Okay, so the first thing we look at says graph y equals 4 times 2 to the x minus 3 plus 2. So we start by just graphing this, 4 times 2 to the x. Okay, so that is actually, it tells us, that's the same one that they used in example 3. So I'm going to scroll up to example 3. My elevator music. Okay, so when we graphed this was the table that we got. And it looked like this blue one right here. So if we notice, we can just take those points and use them. So we have the point 0, 4, 1, 8, 2, 16. So I'm going to write those down. 0, 4, 1, 8, and 2, 16. Okay, so then what we do, we now take, since it is a minus 3 up here with the x, that tells you to go left or right. Since it's negative, this is actually backwards if you remember from translations, that would be 3 units to the right. Plus would be left. and then we have a plus 2 out here. That tells me to go up 2. If it was minus 2, it'd be down. So from those points, so like the point 0, 4, they went ahead and showed us it on here. I would go 3 units to the right. So here's 2 because it counts by 2s, 3, and then up 2. There would be a new point. Okay, the next one was 1, 8. They don't have that graph, but I'm going to do it. 1, 8. Oh, yeah, they do. Okay, so 1, 8, right 3. So there's 2, 3, up 2. There's another point, and I'm going to do the other one, 2, 16. So 2, 16 would be 3 to the right, up 2. So from those points, we would graph. And it's hard to tell this way, but we could just look at those other ones that we had. So we had negative 1, negative 1, 2. So then 3 to the right, up 1. Negative 2 was like, I already forgot. We're going to go look because I can't remember. Negative 2 was negative 1, or positive 1, I mean. Okay. So negative 2, 1, we would go over 3, up 1. So whereas this one gets really close to 0, this one gets really close to 2. So now if we state our domain and range, our domain, the x value is still all real numbers. But now it really approaches going straight, and it says approaches the line y equals 2, but I'm not worried about that. It just approaches 2, but it never crosses it. So your range would now be y is greater than 2. Okay, so we're going to try one of those because I know this takes time. So we're going to try the problem that I write because there's a video for it instead of number 7. So 3 times 2 to the x minus 1 power minus 3. So you're going to graph that function and then describe the domain and range. So pause the video, try that, and then we'll go over it.
Graph y equals 3 times 2 to the power of the quantity x minus 1 minus 3. Describe the domain and range. Begin by graphing y equals 3 times 2 to the power of x. Notice that the equation y equals 3 times 2 to the power of the quantity x minus 1 minus 3 is of the form y equals a times b to the power of the quantity x minus h plus k. Rewrite the equation to identify h and k. Here h is 1 and k is negative 3. Because h is 1, you want to translate the graph y equals 3 times 2 to the power of x 1 unit right. And because k is negative 3, you also want to translate the graph of y equals 3 times 2 to the power of x 3 units down. So the point 0, 3 maps to the point 1, 0, and the point 1, 6 maps to the point 2, 3. Notice that the graph approaches the line y equals negative 3 but does not intersect it. Now you want to find the domain and range. The domain is the set of all possible x values. From the graph, you can see that the domain is the set of all real numbers. The range is the set of all possible y values. From the graph, you can see that the range is the set of all real numbers greater than negative 3, which can be represented by the inequality y is greater than negative 3.